Good morning, class.
Good morning.
Alright, today we are going to look at place value of numbers in base 2, 5, and 8. At the end of today's session, we should be able to recall that numbers in base 10 can be written and in expanded notation. We should be able to relate expanded notation in base 10 to a product of multiples of 10. We should be able to compare expanded notation to other bases and determine place values of digits in other bases, right? Today we are going to first look at the development of the number system that we are accustomed to. We are accustomed to the base 10. Take a look at this. If I were to write any number, let's say if I were to write the number 165, 165. Notice here that this number doesn't have anything below here. That is because it's understood that it's in base 10. Let's see why we say that it is in base 10. Let us look at this. We have here a table of base 10 number. Here use only the digits 0 to 9. No more. And because of the fact that we use 10 digits to form all these numbers, this system is called base 10. This is equivalent to 3 times, what's the value of this 3 here? 3 times 1,000 plus 4 times 100 plus 5 times 10, good. Plus 6 times 1, not so? Now, take a look at this. This expansion is called expanded notation. But we can write these numbers as products of multiples. They are written in products of multiples of 10 years. But we can write these numbers as products of powers with the base 10. Let's check it out. This is equal to 3 times 10. 1,000 is equivalent to 10 cubed. Is that correct? Because 10 times 10 is 100, and 100 times 10 is 1,000, right? Plus 4 times 100 is equivalent to 10 squared. And 10 is equivalent to 10 to the power of 1. Now, although we did not discuss this before, let's look at the pattern. We started here with cube, went to 2, then to 1. What do you think this would be? 6 times 10 to the power of 0, exactly. Now, this is a rule in indices that you must remember when doing bases. What is the rule? Any number written to the power of 0 is equivalent to 1. Let's look back at this expanded notation a little carefully. Watch. Now, if I were to put these in powers of 0, 1, 2, 3. Watch this. I started using whole numbers from 0, coming up till I reach the maximum here. 0, 1, 2, 3. Okay? Now this could have been written quite easily with this line being omitted. Take a look at this. It would be 3 times the base multiplied by this power. Here would be 4 times the base to the power of 2, as in this case. Here would be 5 times the base, 5 times the base to the power of 1. And here is 6 times the base to the power of 0. And you could recall any number to the power of 0 is equal to 1. You start off to the power of 0, then to the power of 1, then to the power of 2, then to the power of 3. Alright? So in expanding notation, this will be 1 times the base, which is 2 to the power of 3. Okay? Plus 0 times the base. What is the base? 2. To the power of 2. Alright? Plus 1 times 2 to the power of 1. Plus 1 times 2 to the power of 0. Okay? So this in expanded notation is this. Are you following me? If I were to have a number, let's switch back to the same base 10, like 203.765. Let's look at this. Now, anytime at all that a 10 is not written in the bottom here, then it's understood that it is in base 10. Let me repeat that. Anytime at all there is no number written to the bottom here, they call it, there's no number subscript here. If there is no number subscript here, then it is understood that it's in base 10 that you are working in. So this is indeed in base 10. If you were to write this number in expanded notation, take a look at this because this is slightly different. Now, to the right of this point, we would start to count starting from 0. This would be 0, and that is 1. Okay? But what you do, you think about this thing as the number scale. The number scale of integers. When you go this direction, it's kind of opposite. But if you go this direction, it will be positive, right? If you go this direction, in terms of the value of the numbers, it will be negative. So this is to the power of minus 1, minus 2, minus 3. Okay? Take a look at it carefully. So this will be equal to 2 times 10 to the power of 1 plus 2 times 10 to the power of 0 plus 7 times 10 to the power of minus 1. Very good. Plus 6 times 10 to the power of minus 2 plus 5 times 10 to the power of minus 3. Here, there is a law in indices that you need to follow here again. Let me remind you of this law. And the law states that whenever you are given so that again?
10. 3 by 10 by power 0.
3 times 10. Oh, thank you. Right. You were paying attention. Very good. Right. There's a law that you need to keep in mind. If I had any number, let's say a general number A, written to a negative power, let's say B, that is the reciprocal of that number written to the positive power. Now that sounds like gibberish. So let me remind you, using numbers. If I had, let's say, 3 to the power of minus 1, that is the same as saying 1 over 3 to the power of positive 1.